All right, here's your final review video of Unit 12. Talk about the shutdown rule and the long run. So let's dive into it. A shutdown rule is pretty simple. Whenever the price or Mr. DARP, which is all the same thing, so whenever marginal revenue, whenever demand, whenever average revenue, or whenever price, any one of those is correct. When they fall below average variable costs, then you should shut down, right? And so oftentimes this is a dead giveaway because you only see average variable costs when they're asking a question about the shutdown rule, okay? Because we don't need it to determine revenues, costs, or profits. So the reason for this is because the losses are greater than the fixed costs. So we take a look at this graph over here. We see our profit maximizing, or we can also say our minimizing point, our loss minimizing point is going to be where MR equals MCS right here, quantity of 5. And a quantity of 5, or total revenue, which is going to be price times quantity, is 45. Our total cost is 11 times 5, which is 55. So we have a loss of $10. But notice this loss represented by this large square is actually bigger than our fixed costs. What are my fixed costs? Well, it's the distance between AVC and ATC. We know that, right? AVC plus AFC equals ATC. So that distance right there is going to be my average fixed cost. So it's going to be $1. My average fixed cost of $1 times 5 is $5. So my losses are 10. My average my total fixed costs are 5. So it's actually cheaper for me to shut down, pay my $5 of fixed costs, and be out than it is to produce any at all. Because in best case scenario, I'm losing $10 rather than $5. That's why you shut down, because losses are larger than your fixed costs. So it's cheaper to just pay your fixed costs. Right, so you minimize your losses by shutting down. So be careful with these ones. If ever you're asked what the loss is when you have a shutdown rule, the answer is, well, because I shut down, I produce nothing. So it's not actually going to be the losses at a quantity of 5. It's the losses as a quantity of 0. And those losses are only your fixed costs. So you have to calculate your fixed costs. So this one has a loss of $5, not a loss of $10, because I produced 0 units because Mr. Dart fell below AVC. That's the logic behind it. As long as you can visually identify that Mr. Dart fell below AVC, you should be in good shape on that one. All right, let's keep going. Let's look at the long run here. In the long run, what's going to happen? Well, we have two scenarios. In the short run, we can have profits or we can have losses. So what's going to happen in the long run if we have profits? Well, if we have profits in the short run, then those profits, I'm pulling my marker here, those profits are going to attract new firms to the market. Remember, there are no barriers to entry, so I can enter and compete with you pretty easily. As a result, the supply is going to shift to the right in the industry. When that happens, the price falls. More firms in the market, more competition drives the price down. We know this, right? And revenues will fall for every firm. And when the revenues are falling, Mr. DARP is decreasing, going down until total revenue and total costs are equal, right? So supply shifting right will lower the price, which also lowers Mr. DARP until we have no revenues, or I'm sorry, no profits or losses at all, where our economic profit is 0. And this is identified at the triple intersection. Check it out right here, right? Our price is 15, our quantity is 8. So 8 times 15, $120 is my revenue. At the same point, my average total cost is also 15. My quantity is still 8. So it's also $120 for total cost. So total revenue equals total cost. My profits are 0, right? In other words, we have a normal economic profit. We know that in perfectly competitive marketplace from last unit, when we have perfect competition, that we are always going to have an economic profit of 0, which means we have a normal profit or a positive accounting profit. In other words, average total cost and price are going to be equal, because when those are equal, that means that my total revenue and my total costs are equal. This is long run equilibrium. There's no incentive for firms to enter. There's no incentive for firms to leave, right? You need profits to attract firms in. You need losses to scare firms away. If the profits and losses are 0, then there's no reason for firms to come in or firms to leave. We're at long run equilibrium. We'll stay there unless something else happens, right? Unless demand shifts right and creates profits again, right? Because any change in the price is going to have a direct impact on revenues. So if price goes up, revenues are going to go up. Price goes down, revenues are going to go down. Okay, what about a loss? Well, in a loss scenario, firms will leave the market. When they do that, supply shifts to the left. When supply shifts left, price rises. When price rises, so do revenues. They're directly connected. Revenues rise as well. When revenues rise, it gets rid of our losses, right? All firms are getting more revenue because firms are leaving, so they get a higher or bigger piece of that pie until TR equals TC once more, right? Triple intersection where there's no incentive firms to enter or firms to leave because our economic profit is zero because total revenue and total costs are equal. Okay. Remember, this is only the case when we have a constant cost industry. A constant cost industry means that when firms enter the market, there's no impact on marginal cost or average total cost. They remain constant. This is actually not true in general, right? When new firms enter the market, competition goes up for these prices of the resources, so costs rise. And when firms leave, costs decrease. But for this unit right now, we're going to keep those costs constant so that we can show those changes and get to long run equilibrium. That's it. That's all the content you need to know. Check out those other videos, the graphing videos, for what your FRQ might be. You are going to have to do exactly this. Pay attention. You're going to have to draw a perfectly competitive market. I'll give you a profit, loss, or I might say it's in long run equilibrium. You have to draw it there. Then you have to analyze it. You're going to have to tell me what region is total cost, what region is total revenue, what region do we have a profit or a loss, right? And then you need to be able to explain what will happen in the long run. If there's a profit, be able to explain that it'll attract firms in, which will lower price, which will lower Mr. Dart, which will get rid of revenues until we get back to TR equals TC. Okay, if you can do that, you're going to be in really good shape on this. All right, good luck tomorrow. See you later.